Now in this lesson we consider the area of a sector. Let's look at some examples. We're asked to find the area of this sector correct to 1 decimal place. Now if we consider this as being part of a whole circle, and because we're dealing with area, we'll write that area equals pARt squared. But you will notice I left a little bit of room in front of the pARt squared for a fraction. Let's see. Now the fraction required is 60 degrees, write that down, out of a full circle, which would be 360. So we've got 60 on 360 as the fraction we're interested in. So let's see what we've got. 60 on 360 pi, let's write that down. And then we multiply by r squared, where we can see that the radius is 7. So we multiply by 7 squared. And when we calculate that, it works out to be 25.7 square centimetres. We've rounded it off to 1 decimal place. Excellent. Our second example here, we're asked to find the area of this composite shape. And we need to answer to the nearest square centimetre. Okay, it's a composite shape. It's made up of a half circle there, we'll call area 1, and a rectangle, area 2. So let's concentrate on the half circle, the semicircle. So because we're dealing with a circle, we'll write down the formula, area equals pARt squared, but it's only half a circle, so we put that half in front. So a half of pi, we'll write that down, half times pi, and we need to multiply by the radius squared. Now, if we think about that 18 centimetres, the radius of the semicircle would be half of that, wouldn't it? It would have to be 9 centimetres. So we multiply by 9 squared. And entering that in on the calculator, we get 127.234 square centimetres. Excellent. Now the easy part now, just the rectangle. Can you remember the area of a rectangle? Well, area equals length times breadth, where the length is 18 and the breadth is 10. So we have 18 times 10, and we work that out, we get 180 square centimetres. Our final step then to find the area, it's area 1 plus area 2. There's area 1 and there's area 2. So we need to write them down and add them together, and we finally get 307 square centimetres, given that we've rounded it off to the nearest square centimetre. Fantastic. Our third example, we're asked to find the shaded area. Now a little bit tricky this one. If we can think of the whole thing being shaded in, and then we get rid of that quadrant. Okay, it's actually a quarter of a circle, known as a quadrant. So it's the whole thing shaded in, and then get rid of the quadrant. And that quadrant we can see is a quarter circle. That's why it's called a quadrant. Okay. Now that circle, a quarter circle, has a radius of 6 centimetres. All right, that's the radius. So we've got a quarter circle there. Mark it in on our diagram. So let's see how we go. Firstly, the area of that's a square, isn't it? So the area of the square will equal 6 there by 6 centimetres as well. So 6 times 6, and works out to be 36 square centimetres. So that's if the whole square was shaded. Then the area now of the quarter circle, because that's what we subtract. So the area of the quarter circle equals, well, pARt squared, that would be a whole circle, wouldn't it? We want a quarter, so we write that quarter in front. So a quarter pi, let's write that down. Then we multiply by the radius squared, which we already decided the radius was 6. So we multiply by 6 squared. And doing that on the calculator, we get 28.274 square centimetres. Now final step, the shaded area. Let's think about it. It's the area of the square, that whole square, and then we take away the area of the quadrant. We take that quadrant away. So let's see what we've got. We have 36 there, and we need to subtract the 28.274. So we write that down, and when we calculate that, we get 7.7 square centimetres, and we've rounded that off to 1 decimal place. Terrific. Well, that concludes the lesson. Good luck with your questions.